show that semi-vertical angle of right circular cone of given surface area and maximum volume is sine inverse 1 by 3. So let me take a semi-vertical angle of a cone. Semi-vertical angle of a cone. Here again this is O is a center, and here we take A, and this one is R. OB is the radius and OA is the height, radius, and L is the slant height. AB is the slant height. Now what is given surface area. So surface area of cone, that is total surface area, so that is pi RL plus pi r square. Should not get confused. Surface area given is always total surface area. They may mention here total surface area, or they may say only surface area, but they should take total surface area, that is pi RL plus pi r square. So you can make it as S is equal to pi RL plus pi r square. Now we are required to maximize the volume, that we leave some space. We write here volume V is equal to volume of the cone 1 by 3 pi r square h. So here I have h and L. So here we need to use this S either by eliminating small l or by eliminating small r. But small r can't be eliminated because this is there in the two terms. So we eliminate L from here. That is S minus pi r square is equal to pi RL. And L now will become S by pi r minus 1 by r. If you look at pi r coming down, pi and pi cancel. Oh sorry, this is small r. So pi r square by pi r, pi cancel, r square by r is r. So here its h, I may write pi by 3 r square under root L square minus r square. H square, using the Pythagoras theorem, L square equal to h square plus r square. Here h square will become L square minus r square, and h will become under root L square minus r square. Now here L, I eliminate this. So pi r square by small r under root of, you can write S by pi r minus only small r whole square minus r square. Remember this L is having a square. So here we have a root. I have told it is already given S, so this is a function in R. But before going to that, we can do the squaring on both sides. Before that we write V, we make it as V square is equal to pi square r power 4 by 9, and this one will become S by pi r minus r whole square minus r square, because the root and square will cancel. That is the reason we have done a squaring on both sides. So now this will become a function in R. So this is pi square r power 4 by 9 S square by pi square r square. We are expanding this minus 2 S by pi r into r plus r square. Remember here minus r square is already there, which will be cancelled. Now the continuation, I finally got f of r is equal to pi square r square by 9 S square by pi square r square, sorry it is r power 4 here in the previous step, minus here r and r gets cancelled here. So here you may bring it here minus 2s by pi, that's it in the closing. R power 4 if you take inside, pi square by 9, r power 4 going inside will become s square r square by pi square minus 2s r power 4 by pi. Now here this is a function in f of r. I do the dash of r, pi square by 9 into 2s square r by pi square. 1 second. So here minus, if you differentiate it will become 8s r cube by pi. 4 to the 8 and r cube you have got So one more time, if you differentiate, we have to differentiate 2 times for maximum minimum. Pi square by 9, and it will become 2s square by pi square minus, and we have here 24s r square by pi. So these 2 times differentiation. But to get maxima or minima, I should do f dash of r equal to 0. That is, f dash of r equal to 0. That means pi square by 9 can't be 0, so you have to take this. That is 2s r by pi. If you take common here, 2s r by pi, of course pi square by 9 is also there. So when you take common, I get only s by pi minus, you have here 4. I am s and r has gone out, r square only equal to 0. We are interested to find out r. That means here we have to find r. So we do what? I take s by pi equal to 4r square. R square will become s by 4 pi. This is r square. When you have r square over here, this means r is equal to under root s by 2 root pi. I put this one separate. Now r square is this much. Let us recall that what is L square? L square is equal to, we have taken h square plus r square, but again we have a small l value taken as s upon pi r minus small r. Here r value I can put L is equal to s upon pi, r is under root s by 2 root pi, and then minus r is under root s by 2 root pi. So here s and root s, it will go up as root s by here root pi, and then 2 will go up minus under root s by 2 root pi. So we will have LCM 2 root pi. So we get 4 root s minus root s, which is 3 root s by 2 root pi. This finally will become L is equal to 3 times the bracket function. If you remove the 3, root of s by 2 root pi, which is given as small r, so 3 r I may get. Now 1 upon 3 here will become r upon L. If you look at this, r upon L is nothing but sine theta in our discussion, so theta becomes sine inverse 1 by 3.